What's going on, y'all? It's me, Matthew Trip Zeta, and today I want to talk about one of the simplest, most primitive, but also most confusing topics in all of physics: time. Now, science fiction, popular culture, and even many modern scientific theories may have you asking the question, what even is time anyway? Can we travel in time? And if not, then why do people talk about time like it's something we can travel in as if it was space? Now, a lot of the confusion comes from mixing together three different things: change, measurement, and chronology. Time in the ordinary, everyday usable sense is a measurement, and more specifically, it's how we track the rate and order of change. Now, that sounds simple, and it is, but people keep trying to turn the measurement into the thing itself. A clock is not time. The sun is not time. A second itself is not time. They're all just repeatable physical processes that we use as reference points to compare other processes against. So when we say that an hour's passed, what we really mean is that some standardized amount of change has occurred relative to some other chosen reference process. Okay? That gives us a relative frame by which to judge the change. Meaning, even though the Earth rotated, the sun moved across the sky, a pendulum swung, or an atomic transition repeated, all of those are measurable changes, but they're not proof of some invisible cosmic master clock ticking behind the universe. Now let's bring in Einstein. Einstein tied space and time together in a brilliant and elegant way, because motion, position, and clock readings are not independent in our frame of reality. In relativity, different observers can measure different elapsed times depending on their motion and the gravitational conditions they're in. So there's no single absolute universal clock that everything in the universe shares equally. Gravity and motion are not affecting time as if it were a physical object. They're affecting the relative measured change between two systems. And that's why there's no single absolute universal clock that everything in the universe shares equally. Because everything in the universe is sitting in its own relative frame depending on its motion and gravitational influences. And that part matters a lot. Relativity does not give us a cosmic stopwatch. It gives us relations between events. So yes, clocks work well. Yes, measurements are real. And yes, physics can be precise. But what relativity actually shows is that clock readings are frame dependent. Motion and gravity affect measured duration, and that means that what we call time is not a single universal flow identical for all observers. Now that leads us to the most common objection. Okay, what about the speed of light? Isn't that objective? And yes, the speed of light in a vacuum is an objective invariant in relativity, but that still does not make it a universal clock. Speed of light is better understood as a universal causal limit. It sets the upper bound for how fast information influence can propagate through space-time. It is objective, but it's objective as a constraint, not a universal timepiece. And this is where the key distinction comes in. There's a big difference between clock time and chronology. Clock time is a measurement, chronology is order. Chronology tells you what comes before what follows what, and what can even count as a cause or an effect in reality. And that is deeper, because even if different observers did disagree about elapsed time, reality still has to remain coherent. If event B depends on event A, then event B cannot simply happen first without breaking the logic of the sequence. That is why the real question is not, can time stretch like a physical object? It is, can physical effects precede causes without breaking the actual system that constitutes the event even being an event in the first place? And that brings us to the real philosophical pressure point. People imagine an abstract timeline like a line already laid down with events placed on it like markers, and then ask if we can move around on it. Put simply, the universe doesn't need a cosmic clock to stay coherent. It needs ordered relations between events. Now, let's go to a simple example. Let's say I want to get from point A to point B. The issue is not that time is something holding me back, or that I can only move as fast as time allows. The issue is that no matter how fast I go, I cannot arrive before the actual event chain that constitutes the journey has occurred. In other words, I cannot get there until I have gone there. That sounds almost stupidly obvious, but that's kind of the whole point. And that's because arrival only makes sense if there's an order. Departure, motion, then arrival. If that order collapses, then go and come, or before and after, lose stable meaning. And once those lose stable meaning, you're not just doing strange physics, you're threatening the logical structure that lets events be events at all. So the key thing to understand is it's not that clocks or light magically limit reality. It's that reality has an order. And time is our only way of tracking that order. So time bends and warps because our abstract measurements must bend to reality to remain coherent, not the other way around. Think about it like this. If literally nothing changed anywhere in the universe, there'd be no operational way to distinguish one moment from another. In that sense, time without change becomes empty as a measurement concept. Once change happens somewhere though, time talk becomes meaningful again because one event can be related to another. But the thing that keeps reality from collapsing is not the measurement. It is the structured ordering of change. Time is our measurement of that change. Clocks are tools that compare one change to another. Relativity shows there's no universal cosmic clock. The speed of light is a universal causal limit, not time itself. And the deeper structure beneath all of this is chronology, the ordered relation of before and after and cause and effect. Reality and change are the territory. Time and distance measurements are with the example that I used in existential logicism. You can create what looks like the past, and you can go kill what looks like your grandpa. And the version of you that would have existed in that newly created reality may never exist. But that wouldn't actually be you, and it wouldn't actually be your grandpa, and it wouldn't actually be your past. Because you still would have existed, and those things would have chronologically happened after you. And that's it for today. I hope I took a little bit of the confusion out of time for you. Don't forget to check out the books, Existential Logicism, Determined Recursive Resolution State Interface. I've also just dropped closure cartography in the annular branch. All of that's up on Zenodo and also on my website, existential logicism, MatthewTrippZeta.com. So I hope y'all check it out, and I hope y'all have fun.